Today we will be talking about intermolecular forces. Until now, we've been talking about intramolecular bonds, or the bonds that hold together a molecule. Today we were going to start talking about intermolecular forces of attraction, or those forces of attraction that hold molecules near each other. Intermolecular forces of attraction exist between molecules or covalently bonded compounds when they are sufficiently close to one another. The greater the strength of the intermolecular force, the higher the boiling point of the substance. There are three main types of intermolecular forces of attraction that we will be discussing. The first is called dipole-dipole interactions. The second is called hydrogen bonding. And the third is called weak intermolecular forces, or van der Waals forces, or London dispersion forces. Those three names may be interchanged. In addition to those three, there might be an interaction between a molecule, or covalent compound, and an ion. That would be called a molecule-ion attraction. We will describe these four things in the next few slides. First are dipole-dipole interactions. Dipole-dipole interactions are forces of attraction between polar molecules. Another name for a polar molecule is a dipole because it has two poles, a positive pole and a negative pole. An example of this would be SCl2. SCl2 is a polar molecule, and so one side of the molecule is positive while the other side of the molecule is negative. When multiple molecules of SCl2 are near each other, they will arrange themselves so that the positive end of one molecule will be near the negative end of another molecule, and the positive end of that molecule will be near the negative end of another molecule. And as they come into contact with each other, they will rotate so that putting the positive of one next to the negative of a separate one. Another type of intermolecular force is called hydrogen bonding. Don't be fooled by the name. Hydrogen bonding is not an intramolecular bond. However, it is an intermolecular force. Hydrogen bonding is a special type of dipole-dipole interaction involving polar molecules, just as dipole-dipole interactions do. However, those polar molecules must contain hydrogen and either fluorine, oxygen, or nitrogen. These three atoms are the smallest and most highly electronegative of all the elements on the periodic table. Because of their highly electronegative ends, these molecules form hydrogen bonds, and hydrogen bonds are the strongest of the intermolecular forces. This accounts for the high boiling points of water and other molecules that contain hydrogen and either fluorine, oxygen, or nitrogen. Draw 5 molecules of water and use a dotted line to show the hydrogen bonds. Here's an example. If this is one water molecule, then the partial negative end would be the oxygen end, and the partial positive end would be the hydrogen. So as water molecules arrange themselves near each other, the positive end of one molecule would be next to the negative end of another molecule, and this dotted line would represent the hydrogen bond. The last type of intermolecular force that we'll discuss today is a weak intermolecular force. It is also called van der Waals forces or London dispersion forces. These forces are weak because they occur between nonpolar molecules or between noble gas atoms. Because nonpolar molecules do not have a strong positive or strong negative end, they do not have a strong electrostatic force between particles. Therefore, their intermolecular forces are very weak. Since these forces are weak, the substances that have these intermolecular forces have very low boiling points. Nonpolar substances with higher masses have stronger forces. So if we are comparing the intermolecular forces between helium atoms, they would be much weaker than the intermolecular forces between krypton atoms, because krypton has a much higher mass than helium does. Also, the closer the particles are together, the stronger the force. So even though a substance may have weak intermolecular forces, if the particles of that substance are closer together, the forces of attraction between those particles will be higher. Finally, we have molecule-ion attractions. This is the force of attraction between a molecule, or a covalent compound, and an ion. It occurs when an ionic compound is placed in water. When that happens, the ions will dissociate. That means they will break apart from one another and will have the ability to move around. For example, if NaCl solid is placed into water, you will get Na plus ions and Cl minus ions that are aqueous, or mixed with water. These two ions will have the ability to move around. So when they move around within the water, the hydrogen end of the water molecule is going to be closest to the Cl minus because, if you recall, hydrogen is the positive end of water. However, around the Na plus ion, the water molecules will arrange themselves so that the oxygen, or the negative end of the water molecule, will be facing the Na plus ion. Because these Na plus and Cl minus ions can now move around, you have mobile ions, or mobile charged particles, which will allow for the ability of an aqueous ionic solution to conduct electricity in the aqueous phase. Let's review a little bit about intermolecular forces. Dipole-dipole interactions occur between polar molecules. Hydrogen bonding occurs between polar molecules that contain hydrogen and either fluorine, oxygen, or nitrogen. Weak intermolecular forces occur between nonpolar molecules.